want like what the question is word for word, or do you want like a sum of it?
Let's see, was it, let's see, where's my, here it is, okay. So yeah, go see, do the best you can with that, and let's see if I can just,
So the question was asking, use the power reducing formulas to rewrite the expression as the equivalent expression that does not contain powers of trigonometric functions greater than 1.
okay,
And the problem that it gave was 17 sine to the power of 4x.
okay. All right, and see, the idea is you can write whatever you want, but you can't have anything higher than the first power.
Mm-hmm.
So it may be that what you wrote was okay, and maybe it's possible that I have to go in and check and see, or look through your test and see what you wrote. Maybe you wrote something that was equivalent, but
Well, I had just no idea how to do it because I don't
how to
remember.
start it.
Yeah, how do you, like the power reducing formulas like looked? I don't recall those at all.
Okay, so those are the we've got two of them. One of them is the sine squared. It's equal to 1 minus cosine 2x over 2. And the other one is the cosine squared. It's the 1 plus 2x. Cosine 2x. Cosine 2x over 2. So those are the power reducing, because it'll reduce something that has a power of 2 down to something that has a power of 1.
Mm-hmm.
Now, so it's you might say the right side of this is more complicated than the left, and why would you want that? Well, you want to reduce the powers, so that's what's important. So over here, you'd have to start with pretty much ignore that 17 until
Mm-hmm.
we can throw it back into the expression, but you'll have you can start with the sine squared of x, and then that can be squared. So you can begin right away by replacing that sine squared with 1 minus cosine 2x over 2. And then that has to be squared. Okay, so we're not out of the woods yet, because this square up here will introduce higher powers in here. So you
Mm-hmm.
just hope for the best, and I'll write this as 17 over 4. So I'll pull that 2 squared out. I'll write it like this. And then I have this thing that has to be squared. Okay. And then we'll just write that. We'll write it as 1 minus 2 cosine 2x plus a cosine. Now this is 2x. I lost that x in there. This is cosine 2x, and that will be quantity squared. So it'll look like that. Okay, so now we still aren't done, because we've got a cosine squared right here. So you
Mm-hmm.
have one more step, and that's, well, one more attempt here. 1 minus 2 cosine 2x. And you'll write this thing using this formula up here. So we'll get rid of that square power. That's 2 power, by writing this as 1 plus cosine. Now you have to be careful with this, because this was a 2x. It becomes a 4x over
Okay.
2. Okay. So now this is good. This is pretty much finished. You might try to clean it up a little bit, but you can't get these terms to come together anyway. You can write the 1/2 in here added to the 1, but that's about the best you're going to get. So even if you stopped right here, this would be fine, but this would be 3/2 minus 2 cosine 2x, and then plus 1/2 cosine 4x. And that's about the best you're going to get it without,
Mm-hmm.
really, you can't get it to look any nicer than this.
Okay.
Okay, so that, and you know what, we actually did have an example like this where I think we were still in class at the time, and it was on one of the handouts that we talked about in class. It was only one problem like this somewhere in there. I think we did do it early in chapter 3. When we first hit that formula somewhere.
Mm-hmm.
But this it's just one problem. It shouldn't hurt you too much.
Mm-hmm.
So anyway, that's it. That's all. That's what they wanted you to do, and it was some work. It was some work. Maybe a little more than you expected that you'd have to do, and that might be what threw you off. So, was there anything else?
No, because the other ones that I got wrong, I got partial credit on. So I know like which ones that like I think I messed up on a step, which with my I forget exactly which problems they were, but I probably forgot something because I know with a lot of them I kept like missing like either like a negative sign or something like that. So
Yeah,
but besides that, this was just the one major problem that I was having an issue figuring out.
okay. Yeah, those problems where you're not really sure where to start. Those are the ones that are strange, right? So
Yeah.
that clears that up. So anything else? Anything about any of the homework problems? Anything?
I don't think so. I just need to finish up the last two um
Two
homework
sections.
assignments. Yeah.
So
And
you
then
started those?
yeah, I started them with I forget exactly which ones it is, but I know I only have like 2 questions on one, and then I want to say like I only did like a few on the other one, so I still have a decent amount of work on them, but I'm like pretty much done with them.
Okay. Well, they're pretty straightforward. I talked about those. I think it was last time. Well, I don't know. It was a couple times back, but I got several notes in here that they must have shown up on the recordings because they're in here.
Yeah.
So you basically, I mean, just to give you a quick rundown of the idea, and I mean, you've got your law of sines, which is stated in 3 ways, and it's kind of easy to remember just because of the form. And you'll work on problems like this where you have A, C, and C, B, A. And for different situations, we can use these laws. There's just actually three equations in one here. They call this a symmetric equation. Anyway, it's 3 equations in one, and the idea is that under certain cases, I believe we have the SSA case, and we have the what was the other one? There's 2 cases I outlined.
I know one that I kept seeing was side.
Yeah,
SSS.
now that's when we use the law of cosines for that one. Okay, when you have a side situation. But let me see, I had that outlined in here somewhere, but and these 2 cases are handled by the law of cosines, but the law of sines are these other 2. Let's see where I've got this one, the SSA, and the other one, which was, what was it? Yeah, SAA. Okay, so this is law of sines, and this one's law of cosines, and the law looks like this. Let's see, it comes in 3 different forms. A squared equals b squared plus c squared. Kind of looks like the Pythagorean theorem, but then you've got this correction factor over here. Like that. And there, this comes in three forms. You can also look like this. And then the third one was this form. Okay, so you've got the two laws, and the law of cosine is good when you have this situation. Like, let's say you have a triangle with three sides and you're trying to figure out the angles. You would start with the law of cosines. If you have a triangle with a side angle side, that's a side and then an angle included between another side, two sides and an included angle. The law of cosines gets you started on that. When you have this situation where you have two sides, two consecutive sides and an angle between them, or you've had a side and then two angles that follow it, you would use the law of sines to get you started. Okay, so that's the idea. And so this is for non-right triangles. Okay, that's what we'll just say, non-right triangles. That's what these two laws are good for. Should the triangle break down and become a right triangle, a 90-degree angle stuck in there somewhere that you didn't recognize right away, then this formula over here in particular just reduces down to Pythagorean theorem. And you have a relationship like this, depending on the sides and their locations. And even these will break down on occasion, and you'll get a right triangle that you didn't realize you had before you started. But in that case, these things in here just end up breaking into the, falling into the right triangle definitions for the sine functions. That's what ends up happening. So you have to go through those exercises because this case right here, this is the hardest one right here, okay? Because it's called the ambiguous case. Okay, and it's hard to explain what that means without going through it, but the gist of it is this. When you have, let's say you got a side, whoops, I'm gonna make a new page here. If you got a side of a triangle here is known, let's call that A. And then you got an angle over here, known, maybe we'll call that B. Okay, and then you've got another side. This side down here isn't known, okay? But you do have a side up here known, okay? Now, so the length here is unknown. You have two sides and an angle. This is SSA. So what can happen is that initially you're presented with something that looks like this, and you're trying to figure out, okay, what are these missing sides? So you know B, let's say so this way B, A, and little b here. But you don't know anything else here. That means that the triangle can kind of, this is fixed over here, but you don't know this angle. You don't know this angle, and you don't know this side. You're assuming that the triangle can be made like this. But the question is, you still don't know C, A, and this side's here. So those are the variables in the problem. That's what means that the whole triangle, the side, it might look like this. Whoops. In other words, this side over here, this is fixed. You can't change this. Okay. And you can't change this angle. And you can't change the length of this side. But it might not be long enough to make a triangle. Okay, if this is fixed, this is fixed, and this is fixed, is that enough to actually make a triangle? No matter how long you make this side down here. if this side here is not long enough, it won't reach down. No matter what you make the angle, it won't be big enough. You know, this could swing up here and still not be able to reach the bottom. No matter how long you make this side, and no matter what angle you make this angle here, you won't be able to make the triangle. But you can't tell that ahead of time until you set up your equations. So that's one thing that could happen. The other thing that can happen is maybe that in that configuration, that side comes down and it's exactly long enough to reach this side down here. In which case, you know, this side here's the bottom is, you can make it as long as you need to complete the triangle. Maybe this side up here is exactly long enough. In that case, you have one answer, it's a right triangle. So this case is no triangle. This case is a right triangle. And then you got your third case. I'm going to draw that over here. It's possible you take that same configuration, and remember this side is fixed over here. So let's say it comes down like that. And then you've got, this is fixed, this is fixed, and this is fixed. And maybe it fits like that. You get an angle here, and you get an angle here, and you get this side here. And there you've got your triangle. But the point is that if it's possible that you can take this side and swing it over here, like that, and keeping its fixed length, stretch this side out a little bit, and open this, close this angle up, so it's in here now, and you'd have a third triangle. Okay, so a second triangle, let's put it that way. So you've got two possible triangles in this case. Okay, so this is two triangles. So no triangle, one triangle, 0, 2. That's why they call it the ambiguous case. Now, you have to work through a problem to see what to do when these things happen. And I went through a couple of those in the the videos that I put together for the last couple times here. Up in here, this, okay, here was, this was cosines in here. Let's see, this is cosines. And this was area. Okay, here was an example where I had, let's see what this looks like. Okay, this was a case up here. We had side-side angle, so that's the ambiguous case, and I worked through what you would do. And for this particular example, number 3, it came out to be impossible. In other words, no triangle. I set up my law of sines. I went through, I got to a point where I reached this, and tells me that the sine of an angle A is 1.45. Well, that's impossible, because the sine can't be bigger than 1. So that's what happens when there's no triangle. In the SSA case, you end up with a statement like this that's impossible to solve for the angle A. No triangle. So that's what happened on this one. Okay, then the next one, there's another triangle. This one had 2 answers, because when I came in here, I was able to find A right here. And then I realized with that, the sine of A was equal to 0.500 at 30 degrees. It was also, it was approximately 30. It could also be that same 0.500 at A equals 150 degrees. So this was definitely one triangle here with the 30 degrees. And I constructed that over here, you can see. And then the other case was if I let A be 150. And if I did, then that would produce this other side, or this other length or angle for C. And I would have this other triangle in here with the, this was the 150. And then the angle C got shrunk down to just 19 degrees in here. So it was possible to actually build 2 triangles like that. And this is the rest of the detail down here for those 2 cases. When I finished it up, I got the remaining side C in both cases here. So I built 2 triangles, and here they are. This is one, here's the other one. Okay, so that's the ambiguous case, and you have to watch out for that. And so on this page here, I did both cases. I had no triangle. I think this is 2 triangles, and I think on the previous page I did maybe 1 triangle. Let's see what happens here. Yeah, on this last page right before that, I have the side-side angle, so that's the ambiguous case. I worked it through, and I got angle B was exactly 90 degrees. So this is the case I was telling you about, where the side over here is exactly long enough to come down, just long enough. If it goes straight there, perpendicular, it's just big enough to make this triangle. And you can't really tell when you first look at a triangle if you have that or not, because most of the time they're not drawn as right triangles, so it's hard to see. If we had analyzed this one a little closer, we would have realized, hey, wait a minute, this side is twice that side. This is 30 degrees. Hey, isn't that a 30, 60, 90? But we didn't recognize that right away, and you probably won't be looking for that. So just work through your law of sines, and when you reach this point, you realize, hey, that's a right triangle, and that's fine. Okay, so those are the 3 things that can happen. Exactly one triangle, and then the next page, we had no triangle, and then the one below that, we had 2 triangles. So I assigned some problems in the exercises for you to get a little practice with that. Now, I haven't shown any of the solutions of how I set these things up. I'm just showing you here that the 3 cases that can occur. But the work, you still have to get through the detail of it. And, that's part of what you have to do. You have to practice that with your exercises. And we can always go through a problem if anybody wants to. But, I went through these already, and so it's up to you, whatever you guys want to do.
In the homework, it's there is the equation H equal B sine in A that we can use that can tell us, I think, if it's bigger than an A, smaller than, or it's equal.
Is there a rule that you can use to figure that out?
Yeah, it is in the homework, which they used it. I think H equal B sine A, and if it's H, the height is can't remember it, but if it's equal, that means it's a right angle, only one solution.
Mm-hmm.
If it's smaller, it's 2 solution. If it's bigger, there's no solution.
I'm not aware of that. I don't remember seeing that.
It is in the example where it helps you to solve it, to figure it out if there's a solution or not.
Is it? You say that's in the book, or is that in MML?
In MML examples.
Okay, well that's interesting, because I don't remember seeing anything like that in the textbook itself. Although, it doesn't mean it's not there. I just don't remember seeing it. How to tell right off the top what you have. That'd be nice to know that before you begin. Let's see. Yeah, there is something in the book. Different relationships on page 215 in the textbook. There is something in there. Let's see. Let me just add a page here. They give on page 215 in the textbook. There's a summarization there of the SSA cases, 1 triangle, and it depends on the length of the sides. So you have to have the drawing in front of you, and then just kind of yeah. So anyway, I I didn't realize that you could actually, but the thing is though, you can, you don't have to memorize more things if you just do a little quick checking while you're working through a problem. You know, I mean, I know, you know, memorizing things sometimes happens, but I don't know if anybody has enough time to do the memorizing in certain cases. So, I mean, I would just look through it. As soon as I see that I have this case, then I would be on the lookout for possibly no triangle, exactly one triangle, or two. The two is actually the most work. And it's because you have to do that check. Once you find one triangle, you have to check to see if there's possibly another one. So this one's the most work. This one's the easiest because it's impossible. You find out right away. This one is pretty easy too, because you end up, if it's 90 degrees, then that's it. If this is the case where one of the triangles is 90 degrees. That's it, it's done. So it's this case that's the hardest. This is not right. These are not right triangles, and you have to check to see if it's possible to get the two of them together. Okay, so it's not always possible. You might still just get one. Okay, so that's why they call it the ambiguous case. And when it comes to two triangles, the problem is why it's ambiguous is because normally when you have a triangle, the any two sides, if you add them together, they have to be bigger than the third side. Okay, if you take any two sides, they always have to be bigger than the third side when you add them together. And when we saw that one problem like this, the trouble was we had side over here, and we had this side. We didn't know what this side was. So it was hard to tell. We could make it any size we wanted to make it fit. But the problem is this angle was fixed, right? You can't change that angle. So in certain cases, it wouldn't matter how long you made this side, because this side just wasn't long enough to come down. So sometimes you could spot that right away. Most of the time, we're not drawing these triangles before we start with a compass and a protractor, or a ruler or anything. We're just sort of roughing them in. It's hard to tell. So if we try to be more accurate with our given information and drew the sketch, we might realize right away that it was possible to build either one triangle exactly, no triangles, or even two triangles. So that's it's important to know this, but when it comes to like for the overall course, the whole course itself, what you're going to study for the final exam, it's more important that you've got your basics down. The right triangle trig, right? That's most important. And then calculating, working with angles, whatever form they might be in, radians, degrees, whatever. Being, comfortable with working with angles, finding angles, plotting angles, finding coterminal angles, etc. The right triangle trigonometry, just your basics, the definitions that we worked with, and of course the unit circle, which can actually take the place of right triangle trigonometry whenever you want it to, with the exception of the applications where we solved the right triangles, solving triangles. And then of course this last stuff where we solved non-right triangles, right? Non-right triangles. Then we had our identities in there, thrown in for good measure. And those are important also, but you don't have to be an expert with them as long as you know the basic ones that I told you about. Those are most important, the basic ones. I think those were given at the beginning of section, was it 3.1 or 2? I don't remember. I think it was 3.1. Those include all the Pythagoreans, the quotients, the reciprocals, and the even odd properties. Remember, we did all that stuff. Those are really the basics. The other ones, you're going to pick those up as we went through 3.2 and 3.3. You're going to pick those up as you keep studying into your math classes. And then of course I also need to put down here solving equations. Okay, that's an important tool that you're going to bring with you to your next class. And you never know when it's going to come up, but you'll often be required to solve equations. They might just be very simple equations where, you know, you might have to solve a problem like the sine of theta equals √3/2. Okay, might be something very simple, or it might be more involved, like some of the equations that we saw in that section 3.5. Or it might be something really simple like that. So you have to be comfortable with going back and forth with this stuff. So that's pretty much what you're going to see, that kind of thing on the final. Hopefully you'll feel that it's mostly basic stuff. If you study it enough, it'll seem like that. So I don't know if I answered your question or not, but or if there even was a question. Does anybody have anything else they want to add?
Yes, could you please go to the homework at 3.5 for the last problem, number 25 on the
Okay.
homework?
You know what? Do you have the thing in front of you, or not?
I know, but I can look it up quickly.
I mean, I could find it, but I'm not logged into the MML right now.
Yeah, it's problem number 25 on the 3.5 homework. I can figure it out. It was by luck.
I wonder if that's the same as what's in the textbook. I don't know. You know, I never bothered to check
like
that.
Inverse. Inverse.
So 25. Let's see. There is once. I mean, I doubt that this is the same problem, but this is what's in the textbook. I doubt if it's the same thing because those numbers in there don't correspond to what's here. This is one that I see in the textbook, number 25. But that doesn't mean it looks like your problem.
Yeah.
So, did you find it?
No, I can't find it. It was like about solving sign, and there's inside, there's another inverse sign of the negative √2/2.
Okay.
Something like that.
Oh, okay. Well, I could find it if you want. If you want to just hold on a minute.
Sure.
Yeah. Okay. So let me just dig into that for a sec. Like I said, I'm not logged into my MML right now, but
yes, I find it. It is sine squared half, and then inside half sine, half sine.
okay. So you're saying it is.
It's on 3.3. It's on homework 3.3. The 23rd, the last one.
Oh, okay. Well, let's see if that's in there. Okay, so you're saying it is a sine.
Square, and then inside bracket half sine inverse of 3/5. That's it.
Okay. Okay, so the problem with this one is, see, this is,
Yes, it is this one.
okay. So we have to figure out what this is first. See, the half is kind of ruining everything. You know, if I mean, if the half wasn't there, I would just have the sine. I would have this whole thing squared. Remember, that squared out there is really just this. So if this half was not in here, I would just have 3/5 as my answer, because the sine of the inverse sine is whatever this argument is. But the half is in there, so best thing I could do is treat this with an identity. So what is that identity? Alpha over 2. Remember, plus or minus
Squared 1, I think, minus cosine theta over 2.
So this will be alpha over 2. Okay, so the idea is that the sine of this could now just be this. In other words, I can replace, since this is the sine of a half of an angle, I can just replace this expression, the whole thing, with this. Okay, but this is, remember, this is my alpha now, right here. Right? That's alpha.
Yeah.
So this becomes, and we're going to, of course, we're going to square the whole thing, but so you would have this, and you're going to square it, but you have 1 minus the cosine of my angle here, which is the inverse sine of 3/5. So this is one way you can approach it, over 2. And the whole thing's being squared. So I still got to figure out this in here, though, right? But that's not that bad to do, because when you look at, let's draw this out over here. This, whatever this angle is in right here, we'll call that theta. So over here we would have the sine of theta is 3/5. And you realize right away that that must be a 4. That's the 3, 4, 5 triangle. And the cosine of theta is 4/5. So that's what I need in here. I'm going to square this whole thing out, so the radical's all going to disappear. I'm just going to have 1 minus 4/5 over the 2. So this is an involved problem. I mean, I'm not saying that this was easy. You know, you had to spot some of these things in here. You know, but it was, you know, it's in the section with that identity, with the double angles and the half angles and what have you. So you figure maybe that had something to do with it, and it did, right? I mean, we had to use this idea here to handle that half. See, the problem wouldn't have been as hard, but that half was in there. And the trouble is that if in here, you really don't know this angle. Okay, so I couldn't just say, oh, that's just the sine of whatever this angle was. You could call it theta, right? And then square it. I still don't know what theta is, right? In other words, if I let this be theta here, this angle, the inverse sine of 3/5, I could write it like that, but I still don't know what that is. So that's why I had to do this. Now, if you had a calculator, you just throw the whole thing in, and ultimately you would get this answer down here, which is what? 5 minus 4/10, right? But that's interesting to note that if you're on top of this stuff, if you hold on a second, let me see if I I can find that. I don't have it handy. Yeah, it's on my desktop, but yeah, let's see, where am I here? Somehow I lost it. Okay, but like I said, you could throw it all into the calculator and see what happens. The whole thing, and you know, in worst case situation, that might be what you would try. If you had the ability to do that. And if the answer came out to be a rational number, the calculator would spit it out. It might end up giving you an approximation depending on the expression. And in that case, you might be kind of stuck with an approximate value. But this will come out exact as long as you work it through. Okay? So I don't know if that helps or not.
Hopefully you don't bring it in the example.
Yeah, this hopefully this I'm going to go back and look over the test. I'm not even sure if I had finished it yet. I think for the final, if anything like this is on there, but I don't remember if it was on the last test or not. I don't remember seeing anything like this, but it's been a while since I looked at it. So, but this would be more of a challenge for sure. So, okay. Anything else? Any other questions about anything? If you want to wait a second, I can pull up the calculator. If you guys just want to hold a second, I have to dig it off my home screen. So it's, where is that? It's here somewhere. There it is. Okay. Okay, so like I said, if you want to throw this whole thing in, you would take the sine. Well, we're gonna have to square it, so I'll put the sine of 1/2. So we're gonna take 0.5 of the inverse sine, 3/5. And we're gonna close that up. And we're gonna square the whole thing. There's your 0.1. Okay, a lot easier than what we did, but anyway, like I said, this one turned out to be nice because it just came out nice. I mean, we had a 3/5. If they didn't have a 3/5, this would still work. It just would be some other crazy angle, you know, some other answer. And then you'd have to have a calculator. So anyway, so that's, any other questions about anything? Anything else? This sort of thing in here is really just like, you know, it's like, you know, math people having fun, basically, you know, this whole thing. And just testing yourself to see if you really understood, you know, what is happening with some of this stuff. And just to give you more exposure to it, you know what I mean? Because that's how you learn it. You have to kind of just jump in and see it. Okay, any other questions? Anything else?
No, thank you.
Yeah.
I had a quick question about the final. Is that just going to be on the My Math Lab as well?
Yeah, it is.
Okay.
Yeah, it's and as I put out there, it's optional. If you're happy with what your test scores are and what you're doing so far in the course, and I'll try to update those numbers as they come in. I know everybody hasn't finished the test, and some people haven't finished the homework yet, but I'm going to put those in. Try to update those so that you know where you stand, and if you want to take a shot at the final, that's up to you. If you're happy with your current grade, then you just walk away. But if you want to take a shot at it, yeah, it's on MML basically. In if in a different situation, I might have made a written part of it required, but since it's optional anyway, then I'm not making a written part of the exam. So, I mean, if this wasn't a forced online class or online format, maybe I would have a written part.
Mm-hmm.
But since I'm making it optional anyway, I'm not going to be as strict about that. So, but for some people, it might be a good, it could make a difference for some people to get through the course this way, by taking that final and boosting up the grade. So that's why it's there.
And it replaces your worst test grade, right? Is that how
Exactly.
you're doing it?
Yes.
Okay.
If you decide to take it, that's what I'm going to do with the number. So I would have to go in and manually do that within Canvas.
Okay.
In the grade book, if anybody chose to take it, I would have to just go in and manually switch that grade out.
Alright. Will you have are you gonna do it during a certain time period, the final?
Yeah, it's going to be. Let's see, a little bit down here somewhere. Let's see. Yeah, I had that written for. I had planned. I think I warned you guys I was going to have it on the 12th. It'd be on the Tuesday, and it would be between 10 and 12. So that's the only time it's going to be there.
Okay.
So because it is optional and it is a final, I had to make it a little bit more strict, so to speak. I'm fixing that time and that window to take the test, unlike the other test. So yeah, it's I don't know if did I send out a note to that effect. I thought I did, but I'll double check that and make sure that everybody gets an email on that. Okay.
For the test number 3, how many questions on the test?
14.
Okay, there you go. 14. Yeah, I would have to look that up because I don't actually remember. But
yeah, it's 14.
Was there enough time on that, Jason?
Yeah, I had enough time on it.
Okay, so I thought.
Are they like part 1 and 1, 2, or are they just one part?
All the steps are shown already for what you what it wants you to do on the test. So
yeah, it's just one part. So there's no written part. It's just all one part, and you have, and there's nothing I could really do to control any of this, really. I mean, if students want.
All about Unit 3 or Unit 4 included?
Yes, it's both. It's the 3 4 sections in chapter 3, and 2 sections from the chapter 4. So it's a little bit of everything. And it's only 14 questions though, so that, you know, some of the questions take a little more time, so I couldn't put too many on there. You know, I mean, some of those equations take time to solve, and some of those triangles take some time to solve. So it's reasonable, I think.
So for the solution, let's say if you solve for equation for the solution and you miss one of the solution, will you still get the full, some graded in, or it's
Well,
gonna be?
I have to go in and check. I don't know.
I got partial credit for multiple, like if there's multiple steps that you have to do, you could still get partial credit for it. But if there's only one place where you can put in an answer, then it's just either you get it right or wrong. But the ones that have multiple spaces where you could fill in multiple answers, then you could get partial credit for that.
That's good to know. And I haven't done this yet, but I'm going to go in and look over the exams and see what people put in, because sometimes the student will put things in and maybe they miss a comma or they miss, you know, something isn't right, you know, and it's not critical to the, you know, to the understanding of the problem. They've gotten it right, they just put it in wrong. And sometimes I can tell when I look at the answers that people put in. So I'm on the lookout for stuff like that to see if maybe you should have gotten some credit for what you did. But that's the problem with those types of tests. It's all or nothing, you know, in a lot of ways. You know, you don't really get credit for the work that you did. You're only getting graded on what you submitted. So it's sometimes hard to know if a student understood anything, even though they didn't get any credit. You know, maybe they understood most of the problem, but they just didn't put it together right. So that's the trouble with that, with those tests like that. So in class, I usually would do two parts. You know, one where you're doing the multiple choice, but another one where you're showing me your work and showing me what you can do. Unfortunately, we don't have that option at this time. I mean, it's an option, but it's really organizational nightmare. So, and I was not going to put you guys through that, or myself. So, we got more than halfway through the course before this catastrophe hit. So, I'm happy with that. So, anything else? Any other questions about anything?
For the final again, is it okay if I start the test late? Because I have another final on that day that ends at 10 o'clock. So is it okay if I probably start the final at 10:05?
Yeah, that's fine. You'll be able to come in anytime during that window to open your exam. Well, 5 minutes won't kill you, I don't think. But yeah, it's a window, so you just come in and start when you get there.
Okay.
Okay. Yeah, I wrote a note to myself that I'm gonna go in and make sure that that's there at that time.
Yeah, because I'm most likely going to take the final.
Okay, good. It's good experience. Taking another math test, even if you don't get higher than your lowest one. So there's an opportunity to possibly get the grade higher. So
yeah, I'm sure taking it to try to get an A in the class.
Good. Anything else? Any other questions? Anything? Now we're still going to meet. I think we have one more meeting next week, right? I think, and then after that, final. So I'll be back next week if anybody has any questions, any last minute things. And there was a final review in Canvas. Did anybody see that? What's that? Did anyone see that?
I think I saw a post about it.
It was in one of the modules. It was just a file. I think it was like a PDF.
Yeah, I saw it. It's like a final review. It just says final review is the mod, like the title of the module.
Okay, good. So now that was one that I had put in there. The department issued that, and that was from last semester. Now that was to get you prepped for the departmental final, which we're not doing this time, but still could be a good tool to review with if you're thinking, okay, what am I going to do? I can't go through all my homework sets again. I don't have time for that. That would be a good place to start with that. Give you a good feel for the entire course, good summary of everything. If you can get through that, and I think the answers are there too. I'm pretty sure there's an answer key that goes with it. Pretty sure about that. So check that out before, within the next couple of weeks. That can't hurt. And that's about it. I don't know, how are the rest of your classes going? I'm just curious. Anybody?
A lot of teachers aren't really like doing Zoom meetings for me, at least.
They are. Okay. That's good.
No, they're not.
Oh, they're not.
Right.
Oh. Okay. Well, everybody's kind of doing their own thing at this point. There's no dictates from the administration what anybody had to do. Because
right.
So yeah, go ahead.
Personally, like for math classes, like I definitely prefer a Zoom meeting a lot more, because like a lot of the other classes, you don't really like need the teacher to teach you anything. Like for like a Com 102, you're writing a research essay, so like a lot of research. It's a lot of like work on your end. So
yeah, I could see that. This is more in the sense, like a hands-on thing where you have to kind of see it being done at least. And I know they have stuff in MML. They have some videos. I think I'm pretty sure they have some stuff in there. So that's pretty good. Of course, you can't really ask any questions, but so that's the real big difference. Is that I'm here, and I figured I would be over at the school every Tuesday from 10 to 12 anyway. So this would be good for the students if they wanted to show up. But it's the best we can do under the circumstances. So I'm glad some people did show, because I have other classes where I teach. I've done these meetings and I've had 0 attendance, which is fine. I mean, I didn't require that people show. It's not, I didn't make a requirement, but because the problem with that is that we really don't know as a faculty. We didn't really know, students' schedules, even though they had signed up for a class. We were meeting from 10 to 12, and that's what you signed up for every Tuesday. Nobody knows what's happening in the background now with schedule changing, things going on in students' personal lives, which may have turned their whole schedules upside down. So that's why we were told not to require people to show at certain times on a regular basis. Now, for the final exam, I felt it's a final exam. You got to find time to do that if you're going to take it, So I fixed that time. And besides, I want to have a little bit of control over what happens with the final. That's about the only control I I have. So fixing the time. Otherwise, it's kind of like a free-for-all. So
Do you think they're gonna make the fall e-learning too, or no online?
that's a good question. I've heard people talking about it, but nobody is saying anything. Nobody is committing to anything at this point. Everybody's just looking at everybody else. Okay,
Because
what are
the
they?
governor said that to prepare for e-learning, it might
Yeah,
be an option. So.
right. They're talking about it. They're just dropping the hints in case it does happen. Nobody can say, "Hey, you didn't warn us," right? So I would expect anything at this point. Expect anything. I mean, I've been teaching for 30 years, and nothing like this has ever happened before. So it's all new territory. I know you guys. This is all new for you too, but you gotta trust me. This has never happened like this before. At least not in my lifetime. So expect anything. Also, summer's all online. Are you guys going to take summer classes?
Yeah, I'm
Yeah,
taking
most likely.
Calc 150.
Wow,
Math 150.
wow. You've got a lot of nerve. That's going to be fun. Now, if I wouldn't take an online math class, I would go for the one that was already online. In other words, take it from the teacher who has already been doing online. I don't know. I would just think, well, that person's a regular online teacher for that course, and that would make sense to me. Not that you're going to get, not going to get a fair shake with another teacher, but honestly, a lot of the teachers, everyone's online, but not everybody belongs online. And I'm speaking about the teachers now. So, and that's, you didn't hear that from me, but I think it's kind of like common sense. Some teachers who wanted to teach online, they were teaching online. And other teachers who didn't want to teach online were not teaching online, but now everybody's online. So it seems logical to go with the seasoned online teacher. So, but I thought it was interesting, out of district tuition, and I don't know if this is true for Moraine, but students who are out of district, if they take the class online, they get in-district tuition, even if they're out of district. So that's kind of strange. And I was just wondering if I don't think they can do that for all the classes now that everything's going online. But I don't know. I haven't heard any word on that. I don't know. It's kind of weird, that's all. But so my second question is just out of curiosity. You guys are listening, so I lost one person left, but has being forced to go online influenced your decision to take classes over the summer?
Yeah, I did. I just have to, because I want to just get done. I want to get the math series 150, 151, and 152, and all that, and trigger and all. So like,
you
I
don't
have
want to
no
lose.
choice. I have to take.
Yeah.
If I don't, because I have to take 151, then 152. If I don't take it right now, and in the fall, I'm gonna then be behind a little bit.
Yeah. So that was your plan anyway.
It was my plan anyway, so I had no choice just to take it.
Okay, but you wouldn't necessarily take it online if you didn't have to.
No. Even I'm scared for the fall, because I'm taking 151 already registered, and the math 212, the statistics. So it's they're both big classes. And No, I wouldn't.
Yeah.
I took film appreciation online, which is kind of like easy topic. I took it in the spring. I'm
Mhm.
taking it right now. And it's easy. Like I know what I'm getting into, but the big classes such as chemistry, math, I like to be in the class.
Yeah, how are they gonna do like is there a chemistry class a lab class?
He the lab he gave us the labs with already some data just to do a calculation, and
Okay.
he do really good, giving us like 3 hours recorded video lectures
Hmm.
online every week with the whole like we are being in class, and so it's a long um, lectures video like hour and a half each, and there's three of them because the material is very intense. um and there is some labs we didn't do, but we did the most of it. That he did like calculation for us, like weights and stuff. We just do the rest at home and turn it in online.
Okay. Well, that's good. That's working out.
The only thing he was worried because of cheating, because he said student cheated on the other exam.
Yeah. Well, see, that's unavoidable. I mean, that's you're going to get students who try to do that, and yeah, that's difficult, and especially there are some ways to prevent it, but we most of us we know that we couldn't force our students into that into those regulations in a sense because nobody wants to be online to begin with. So
Yeah.
it's like, well, let's not make it really hard on some of the good students just because there's a few bad ones out there, who you're trying to stop from cheating. um, it's unfortunate, but it's an emergency response we have here, so it's not perfect, but I'm glad to hear that at least your other course is going well. That's
Yeah.
good.
Thank you.
Okay, well, um, well, I'll be here next time. Um, unless you have any other questions right now. And
Mr. Monbrad, I remember like reading in the syllabus how late work is like half credit.
yeah, is that still okay?
Yeah, just like regarding late work isn't like homework and stuff, right?
Yeah, homework, only the homework though.
Right.
The quizzes and the tests, those have to be done by the due dates, whatever the due dates are. But homework should be, I think it was it 50%?
Right. Yeah, half credit.
Okay.
I tried some of the book. I don't know why it's not open.
Which one is it?
I'm not quite sure. And also, I emailed like regarding how I couldn't get into the Zoom meeting last week. I don't know if you remember.
Oh yeah.
But the link that you sent me after it ended. So
You mean
I used that link to get into the one today. But the one that's in the what's that?
the one in Canvas is, you say it's dead? It's a dead link?
Just ask for a password.
Oh yeah, I know. I heard that some of that was happening, and I really wasn't sure. I don't know. Did anybody else have a problem with that?
No, I don't.
Yeah, it seems to be kind of random. Because I've heard some people. I mean, we're all using the same link. It's the one that's sitting in Canvas, right?
Right. Well, no, the one that you emailed me is the one that I used to get in today.
Oh, because the other one didn't work?
Right. The one I asked for a password. Like, it's a Zoom meeting, but I asked for a password.
Really?
Yeah.
Okay. But what about the rest of you? Were you able to use the link that's set up in Canvas?
For the Zoom meeting?
Mm-hmm.
Yeah, I did, but I had a problem last week and a week before for getting in. But today I just put the password and it was fine.
Okay, so it is asking for a password.
It does.
Okay.
What?
Now, so how did you get the password?
The password, I looked it up. It's the one that you sent a couple weeks ago.
Okay.
Because I did, yeah, you mentioned last week that you logged into the wrong class. That's why when we were tried last week to get in, I get in, but it says like you haven't started the meeting.
Yeah.
But I think you were in another meeting. So I
Exactly.
think that's what he's talking about.
Ah, okay. Well, that makes sense then. Yeah, that was my fault. Last week, I have like a list of meetings, and another one of my classes starts at 10 o'clock, and I just, you know, it's the wrong meeting button. I saw 10 o'clock, and I didn't look at the details, and so I missed the meeting because of that. And yeah, that would cause a problem because the meeting wasn't open. But I'm gonna see if I can get those get the password information and just put that on right there next to the link that's in Canvas for this meeting, so you don't have to go searching for it if you need it. I didn't think it really needed the passwords, but like I said, I'm not 100% sure on how all the Zoom stuff works, really. I mean, this is the first semester I've used it, so I mean, I have to apologize, but I was not an expert at the Zoom stuff, so I was lucky to get actually what I got together. Honestly, I was happy that it was actually running at all, but there are some snags. So, but so I'll, you know what? When I go in, I'll fix that. I'll make sure that password is sitting right there, so that when you need it, you can just copy and paste it. So, okay.
Yeah. So the homework that I was trying to do was like probably the first homework from the semester, like 1.1 and stuff like that. It says like you're no longer able to.
Oh yeah, that. Wow. Okay. Well, that was. Let's see. I think initially the latest you could turn it in was like by the next exam. I'm not even sure, but you know what? I can go in and open those up and make them available if people want to go back in and work on them. It doesn't really matter to me. I think anything that gets people in there and working more is fine with me. You know.
All right. Thank you, Mr. Monbrot. I appreciate it.
Okay. I'll set that up. I'll make a note and make those available. Do you know it was just like from chapter 1?
Yeah.
Okay.
Check. I'll check right now if chapter 2 is working.
Okay. So I'm gonna put those extensions in there for the. I mean, it's only half credit, so it's not like I'm giving away the store. So, and if you're getting in there and getting more practice, then that's the important thing anyhow. So.
Yeah, you could still work on chapter 2, but not chapter 1.
Okay, then I'll go in and check that. And okay, so that's I guess that's about all we need to talk about then.
There's another meeting next week, right? Next Tuesday.
Yeah, I'll be back here on next Tuesday if anybody has anything else you want to talk about, reviewing or anything.
All right, sounds good.
There. Okay, everybody.
Quarantining.
Yeah, you guys stay safe, and we'll see you next week if you show. Okay.
Goodbye.
Thank you. Bye-bye.
Bye.